Thank you. I hope you all can hear me. Since Alex said there's no time, so I bring my phone so I know what time is now. This is so good to be back to the stage of Linux Foundation. I haven't seen all of you in 6 years by now. So thanks to the invitation from Arpit. So this topic is not like I come up with the topic, it's he came up with the topic, so I try to talk about it. So this is from Network plus AI to AI Network. Basically, it's to share some experiences and some lessons we learn. I have been working on AI for 30 years, sadly, which means too old. Since 2018, all my talks with Linux Foundation Networking is about AI. So I checked the topic, the talks I have been presented in past years. So there's no clean story. I just share how hard it is. Okay. Is there a way I can? Okay, this way. So first one, what's the purpose we're trying to using AI? We try to use AI to enable our network or whatever transformation you refer to it. This is the reason I choose to join China Mobile back to 2013, because I've been working on AI for speech recognition, for natural language processing, for dialogue, for data analytics. So you always can do something very cool, but when you come to the business side, the industry side, how you can prove the value, no matter value is from social level, money level, whatever level, and the kind of overall package you can bring to the table, that kind of overall value should be way much greater than the R&D cost. So whatever you deploy into large scale use, R&D cost is only a small fraction of it. So my own experience with China Mobile, since I joined, we first 3 years, and we only focus on to change our customer care. So that took us 3 years. We were able to cut the number of customer representatives by 50% within 3 years. That was like back to 2013 to 2016. You know, the number of customer base in China is huge, the largest in the world. So this is the first time from my own experience is you can see that kind of the value come from AI. That's about knowledge, how we can design the knowledge base, how you can AI to train our customer representatives, how we can embed AI in the service pipeline. Since then, we have been coming to use AI to transform the network. That's much harder. We also push the AI into over 50 different business lines inside China Mobile. Also internal enterprise management. And you can name many fields like law departments, sales, marketing, human resource, sales, purchasing. So all the pipelines and processes. It's a long journey, but for every line of business, we try to transform, and this is the formula we have to answer for the company. So today, all the experiences come to how to make this happen. I talk about AI. So I guess every single day, it's not like every week. It's every single day wake up for all the AI researcher and the developer. You will be shocked, the progress, the breakthroughs. That's like quite challenging for all the people working on AI. So for the current AI technology, if we use one word to summarize AI, the main feature is a large language model. Doesn't mean large language model like the model you regularly use for DeepSeek, for OpenAI, for Gemini, whatever the model you use. Frequently you use the language model. which it can understand your language, it can generate, it can reason. And beyond that, you also can do data analytics. You can ask the model to write in Python codes for you. You can generate images, you can generate videos, vice versa. So on the line, there are different kinds of models. One is a large language model, and you have multimodal model. You can have a structured data model. You can combine everything all together. So that's the main feature of the current AI. And the recent progresses, you can use reinforcement learning to let your large model to learn from real experiences and more effectively. And you can do deep thinking, which is not only give you the answer, also shows you how the language model reasons. That's the overall package. So it's not like it can solve all the problem we care. So on the bottom box, I showed you where this AI technology is heading forward to solve those challenges. The number one, hallucination. Hallucination means there's even the best model in the world in any scenario, the average hallucination rate is about 11%. And back to a year and 2 years ago, that was like 25%. So basically, it has a serious reliability problem. When we apply the technology for current round for customer care, so whatever you apply, the company has to be responsible for the robot, whatever it recommends. It's a response to the users. So the number one challenge is how you can control that hallucination rate when you deploy. That's a kind of a fundamental challenge. And it's not, it has the good part, it also has the bad part. And the good part is, even human, as of us, we hallucinate too. Sometimes it's like, the mechanism behind hallucination is quite similar to imagination. So we do innovate through imagining, and the model has that mechanism too. So it imagines something, some facts, it imagines some reasoning steps, and you think it's totally wrong. That's the number one challenge. I'm thinking is with the development of GAI, the hallucination rate is kind of coming down, but it's fundamental. It won't disappear in short term. And second challenge is the collaboration. So no matter all the leaders sitting in the room, no matter how smart you are and how smart your employee or staff are, you have to make them work together. And then we have super cool models, larger ones, you have medium size, you have the smaller models, traditional models. So how can I have them collaborate together for a complex task? It's probably the hottest field in AI. And people propose, you can build some agents out of those foundation model. Then you have agents to work together through like the recent protocol MCP or long chain or other mechanisms. But I'm thinking we're far from having a framework or theory or mechanism really have those supermodels to work together. There are many research directions to explore that field, and then again, we all can open to it. And that's why the platform, AI platform is so key here, and to make sure how you can have many models. For example, in our platform, we have like over 200 larger models, huge models, and you have thousands of the smaller models. How can you have them work together? Plus, you have millions of APIs, and you have all the huge databases. You have complex, the OSS systems, other systems, how can work them together. And third challenge is how to apply AI in a real physical world. And probably in certain factories, if you have ever visited some of those, as having AI enabled, and kind of you can walk to a factory without a person. The second one is in our home, office, our street, in the city, is still quite challenging to have AI to sense our physical world in a correct way, and the reason, and coming up a nice and reliable solution. And it's this year, one of the hot topic on AI is AI for science. Basically, it's the key field beyond proposing hypothesis for scientific research is how you can have coming up an AI model to replace those research assistants in the labs, in the scientific lab. And it's quite dynamic in the lab environment. It's pretty challenging. And the last challenge I want to mention, I think is already covered, is integration. So trying to integrate, because you want AI to really make a contribution, it's not like kind of only converse with you in the digital world. You want it to take actions. So that versus how when we apply AI to enable our large telecom network, you face those problems. So AI is pretty good at serving individual use now. Once you want, you can ask the model to write an article, to answer your question, to translate your speech. Those tasks, when we come to a complex system, it's still quite challenging because the scale doesn't match. And for example, I just give some numbers of China Mobile Network, the size and the reliability. There is a huge gap. And third one is dynamics, so you cannot have a model saying, it's fixed. So the environment is quite dynamic. How can you efficiently learn? And the complexity and the heterogeneous network is also a challenging feature for AI to process. And so the rest of the slides, I'm going to show you some experiences, how we cope with this problem. Let's check the time. I forgot when I started, but anyway, we'll talk 10 minutes more. The first one is in order to, because I think AI come to this stage, you don't want only apply AI to show some demonstration or just to prove the, you can prove the usefulness of AI, because you want to prove that kind of formula I proposed in the first slide. So how can you do it given it's quite complex? So I think the first one is set a high-level, corporate level strategic goal and stick with it, because it's quite challenging for all the companies to make a huge change, systematic change. So for us, that was back a couple of years, we set this to evolve our network, autonomous network, to level 4 by 2025. In order to do this, and we kind of decouple our processes of our network operation into over 800 processes from end to end. And then we analyze, which one we can use AI to enable and what value we can derive from that action. And then what's the common technology, what's the common data set, in order to do that. But during in the past years, you always face huge challenges by the business part, and sometimes by lots of complaints. When you have lots of people to work together, it's set to the purpose and overcome the challenge together. And this is a carefully designed path. It's easy that you can jump into the ocean and do something and without getting far. I think you have to design the passes. The managers and the different parts of the company, they don't have infinite patience in order to the R&D to work on, to try, to fail and redo it again. So I'm thinking it's you need to prove them like the short-term gain, what they can get from you. And then from there, you can move on to another level. So I'm thinking carefully design the path is very important. I share some experiences of how we did it. So basically, we proposed this value-based, value-first strategy. So as I said, we have those hundreds of processes. We evaluate their value, and the high value goes first. And the second one is the end-to-end. So end-to-end means if you have a lengthy process and you're only using AI to change a part of it, and it's hard you can get the great outcome from the end-to-end. So when we design this, you have to have the AI to serve the whole pipeline from end-to-end and calculate the business value for them from end-to-end. That's a nice thing about AI also. For current AI technology, whatever you do, like the research I do during my PhD, you can do the core research, you can try on something small, and you rely on someone else to push into the real production. But for AI now, it's kind of going quite fast. Every sector, you close the loop, and you prove you can just change the customer experience. So the end-to-end is very important. Instead of working on so many, sometimes it's better to work just one, and to show you really can bring the value to the table. Then you can jump to, you can learn the ways of doing it and build a platform to support the whole transformation. Then you can come to next level of the speed of transformation. And evaluate the risk. And in that one, you can slowly build in your platform that the platform can become the foundation to support the whole transformation. That's the first experience, carefully design the path. Second one, as I said, the skill is trying to do the operation. For core is coming, for the future, no matter for AI for network or network for AI, we have to come and change some of the core aspects of the network. Alex already touched part of it. I just have them listed here. We'll not go through one by one. Lots of researchers investment into this. And now I have all the papers in the end. You can look at the papers if you're interested. Clear metrics. So AI is this. You have two ways of to measure. Without metrics, you don't know where you're heading. You have to come up certain, for technological metrics to measure your improvement and quickly develop, retrain, and the fine-tuning. There are many different ways you can improve. You also have the business metric. Even yesterday, we talked to other leaders in this community. Sometimes it's hard to show you, but you have to show to the business people what value you can bring to the table. And the first point, you can agree with them. Sometimes, like when we deployed AI for home service, for network, for individual customers in the law department, finance department. For different one, you need a different strategy to set up the business metric with them and set up the technical metrics. So that way you can align with them, so where you're heading. So maybe under LinkedIn, we can together coming up at least the evaluation data set and then the metrics and the ways of it to measure. There are many different ways, like a couple examples here, like you have a great balanced data set. You can do A/B test. You can do live network test. You can have the comparison tests. You can do the in real, and you check the winning rate of your models. And third one, this one is, I think the fourth experience I wanted is the platform. The models are changing. Every day maybe there's a new model. A couple of weeks you have completely different way of train model. The model's capability are changing quite fast too. So this is a platform. You need a platform to manage all the models and to deploy them and to provide the training and fine-tuning framework. You can efficiently do it. For example, even the foundation model, now almost every month, you can have a new version. bigger version for the pre-trained model. For the fine-tuned enhancement training, for the R1, DeepSeek R1 ways of retrain, it's like every day happening. So you have to do it quite fast and making the wheel turning faster to do this. So this is, I show the framework inside Junlan, which is our platform. You can have the models, agents, tools on the platform. We also making certain inside the company standard. So you can have many agents, you can have many models, but without any designing, without any kind of trying to find what's the commonality, it's hard to control them, hard to have them collaborate. So on the top, it's whenever you have a service need or you have a requirement, we can easily hook up those pieces of technology or either models or tools together to complete that task. That's the scale how with this platform we're able to support thousands of production services in network. And this platform, we have general Junlan platform for China Mobile. We also kind of customize that one for our network. And I will quickly go through certain applications. And I just want to mention there are two levels of applications. One is network plus AI, which means without dramatically changing the process. So the network runs as it is, and you're trying to embed AI into a certain part of it. But you measure the value of your AI contribution from end to end. This one shows the network plus AI application, how we do the base station energy saving. It saves lots of money every year for China Mobile. Basically, the key technology is prediction. When I move to the end of the slides, you can see the papers we published. I think half of them are prediction. So predictive AI. And smart dumb resource management, and that's into operation. You can see it's the service people can wear certain glasses and we're working, and they can use their phone, they can use different devices to guide them, because without AI enabling our people, we send to sites, their knowledge is quite limited. Sometimes you have to send to different people several times with a different technology background to fix the problem. Now with the AI, they guided by the AI agents in the backstage. This is for you can see the cell phone, that's like our model. The service people use this whenever they go to someone's home and they go to the site, they can rely on AI to work for them. Otherwise, they have to, for complex tasks, they have to call the central office and to get help. That's kind of quite welcome, and that's in the hands of our service people. This is, as I said, the closed loop, how we can leverage a structured larger model to build self-looped applications from end to end, autonomous optimization of run. So basically, it's, you hear lots of models, and Arpit mentioned the domain-specific AI. So basically, you can grab a model from open source, or if you have a commercial contract with OpenAI or other ones, you can have their commercial model, general model, and then you can have your own data and to tune the general model to be domain specific. But there's a huge problem is that if you only use your own data to tune the model will lose a lot of the general artificial intelligence capabilities. That's not what you want. So you have to replay quite a bigger fraction of the general data. That's why sometimes it's not easy. You can grab a model to make it work for you, enterprise specific or domain specific. That's also the reason we have our own, the whole set of model. Another model I want to mention is all these models that you use frequently, daily basis, it's mainly based on multimodal data or natural language data. But in enterprise, specifically in the network field, you, like China Mobile, we have petabytes of data every day by operating the network. That's all in your database, and that's numeric data. That's in database, in your data warehouse. How you can infer intelligence using that data, that's the current general model. Have no sense what do you have in there. So we build our structured data model, foundation model to do the automatic analytics, to the prediction, classification, and other analytical tasks. And this one's for operation, and we have this, part of the platform, we have the simulation. Basically, so you have the real data come in, and you analyze, you do prediction. Once you predict how you can adjust your parameters, and for certain scenarios, you can project it back to the network, and then you can see how the coverage, how the optimization results will be. So this one, we have to model the users. You model your physical surrounding, and then you also model using lots of data from the network to model how your signal kind of working together with your user behaviors, how they move, how they use the network. Okay, and then I will quickly go through a couple of papers. I don't think I have the time. I just give you a sense of what's the challenge. So this is a world model aided run parameter adjustment evaluation. The different challenges here is when we're working on run, you are not kind of handle sequential data as most generic models do, like the OpenAI, Google models, and our own Junlan model, same thing. Here is you have to handle the spatial and temporal information. And you have to handle the graph. So basically, all your base stations are connecting in a certain way and have the certain pattern for connecting and serving your customers. They're moving all the time. So it's like an inferencing aided handover parameter. This one, it's you, this one is like adaptive multi-receptive field for spatial temporal graph, convolutional network, for traffic forecasting. And now with the large model, you do the same thing, but you have to handle the same challenge. So the data we get from our network is not like as simple as sequential data in natural language. You have way more factors you have to consider. How you can encode or embed those kind of data, it's still quite challenge. That's what I'm thinking is maybe with open source, we can open up certain of the problems and then ask the younger generations to collectively solve those problems with us. I will quickly go through those. It's hard to talk about the papers. How this is for the large model, it doesn't have the causality. But for network, you want to improve the reliability. So we kind of push into how the reasoning, different way of reasoning into the network foundation model, and knowledge graph, and as I said, we do lots of prediction. This is for how to practical synthetic human trajectories generation. As I said, to build the user models. This is all the papers, the recent papers in the past couple of years. If you're interested, you can take a picture and look at the details. They are open. And vision. This is the vision we came up on AI Plus network. As I said, I cover many kind of applications that we have pushed into real use. And for moving on, as you see how we do the simulation, basically they want to network from invisible to visible. And the second is unified portal. I guess you all pretty much know the scale of our network, and now it's based on one platform. Real-time assistance, it's like all your staff in the whole network, how they can collectively train the model with you and provide feedback to the model. So have to real time give them real help and get the real feedback. That's a key for the models to learn. I guess you all know the breakthroughs close to, I think it's the end of February, before Chinese New Year on DeepSeek. And the key is they find a way of to provide very precise feedback for the big model. That's the reason they get so much gain. They rely on the coding implementation, the facility to provide the feedback. They also rely on math. I think if we come to making our network really intelligent, you have to provide that precise feedback to guide the models to learn. As I said, making it end-to-end workable. So it's an automated closed loop. So this is my last slide. I'm thinking is how collectively we can work together. Alex talked about the data issue. I'm thinking is for the big data, since 2009, when big data become a hype topic, it's so hard to share data across inside the organization, across the organization, especially for telecom data, because you have the data or have certain part of a touch with your own customers. So I'm thinking is there a way we can maybe as the community, you have set up the problem, we can all propose the specific problem we're trying to solve. Then when it comes to the data, it's quite hard for the operators to just, give the data away because there's lots of reliability. And they can host the data on their own platform, but making it have like kind of same interface, the same experience. Then this way, the data is not kind of outside the company. It's also inside the company, but you can have people from outside to come in to work to solve the problem. There are certain technologies to support this kind of way of collaboration to work. I'm thinking maybe it's worth to try. With that, I don't know how much time I used, but thank you.